Let's come to the mathematical implementation part of it. How does a neural architecture looks like? At the first end, I have inputs, and these inputs can be, mind you, anything. They can be text, they can be structured data, they can be images and whatnot. Let's say this can be the age of a person, this can be the income of a person, and then this can be the gender of a person for all I know. Or they can be pixel 1 of an image, pixel 2 of an image, pixel 3 of an image. It can be free text. Let's say it can be a review that we are writing. So let's say a review is like UNP is great. So I have three words here. The first word can be represented by this input 1, the second number by this input 2, and the third by the input 3. No matter what I'm trying to represent, a neural network always starts with an input of data, of the data that we are working with. Okay, so please keep that in mind. We are working with data, and in the first layer I have data coming. Okay, now in the next layer I have these weights and these biases that I have to train, and then I sum it all up, put it through an activation, and then finally I have my output. What do I mean by this? So a typical neural network architecture, to be broken down, it looks like this. I have input, let's say this is 1, this is 2, and this is 3. Okay, weight 1 will be, let's say, 2, and then 3, and then 4, and then 5. Okay, so if W1 equals 2 and W2 equals 3 and W3 equals 4 and the bias is equal to 5 and I3 equal to 3 and all of these things, let's go through this numerical example. These get multiplied. So I have got 1 into 2, so which is 2. This is 2 into 3, which is 6. And then 3 into 4, which is 12. And then finally I have the bias 5. Now all these will get summed up. Okay, so 2 plus 6 plus 12 plus 5, which comes to roughly 25. So here the number 25 is getting passed. I sum all of it up. Okay, so when I sum all of these up, I put it through a summation. So I put it through a summation and out comes 25. And then finally I have some activation. Now activation can be sigmoid, tanh, ReLU, it can be softmax, and a bunch of other stuff. What are activations? Let's take the sigmoid for example. In a simple neural network, the sigmoid activation is the most used activation function. When we go over to convolutional neural networks, we'll see that what are the problems with sigmoid. We'll address some of those problems and move on to a different activation function. But since we are covering simple neural networks here, a simple neural network mostly consists of the sigmoid activation function. What do I mean by sigmoid? A sigmoid is basically defined by 1 by 1 plus e to the power minus x. Okay, so if I put this 25 through a sigmoid, it will become 1 by 1 plus e to the power minus 25. And then whatever the output of this piece of computation is, that will become our final output. Now, why are we using sigmoid here? A sigmoid function gives me numbers between 0 and 1, which will help me understand what is the probability of a particular class. So let's say you're doing digit recognition. doing digit recognition. So either it's a 0 or a 1 or a 2 or a 3 or a 9 there, right? So they have 10 classes. Okay, I need to know, given an image, what is the probability of each of these classes. Okay, so let's say an image comes here and it goes through all these pieces of computation, and out comes a number like zero point 0.7 or something. This will be the probability of it being some digit here. Okay, we'll step through this in details as we go along. So I see that again, this I1, I2, I3, they are basically tensors. W1, W2, W3, the bias, these are all tensors. And then some operations are happening on tensors. Either they're getting multiplied, or they are getting added, or they are put through some activation function. Whatever be it, ultimately, again, tensors are flowing through some operations, hence the name TensorFlow. Okay, so a typical neural architecture looks like this. I have a bunch of inputs, it gets multiplied by a bunch of weights, it gets summed up and then put through an activation function, and finally we get our output. Okay,